So I'd like to welcome everybody who has joined the session. So everyone is attending a talk about, or entitled, "The Algorithm is Not Enough, UX Meets Data Science." And I'm your MC for today's session. I'm going to quickly introduce Scott and Roxana, excuse me, and come back later to help moderate some questions to the speakers, or for the speakers. So first of all, I'd like to say I've had the pleasure of working with both Scott and Roxana at Macadamian. So I'll introduce Scott first. We'll go in order of seniority, Scott, if you don't mind.
Hey. Roxana might have to wait a long time.
Yes. So Scott, over the past 25 years, Scott has worked in the area of business strategy, product design, and development in the high-tech sector. He brings with him cross-sector expertise and experience working with clients in industries such as aviation, telecom, and finance. His primary areas of focus over the last several years has been in healthcare, and more specifically, the intersection of data science and user experience. Scott has a master's degree in physics from Queen's University, and he just recently joined Akendi as Chief Strategy Officer. His focus for the past several years has been improving the integration of multidisciplinary teams that include clinical, business, technical, design, and data expertise, and the enhancement of the tools and practices these teams apply. So, as I mentioned before, I've had the pleasure of working with Scott at Macadamian, and you are really going to enjoy the talk. Next, Roxana has more recently joined Macadamian, and having traversed academia, healthcare, and industry, she has trained as a cognitive scientist. Roxana tackles research questions from various lenses, striving to provide comprehensive, unique, and data-driven insights. Roxana is a sought-after public speaker and facilitator. She's currently got over 30 conference presentations and speaking invitations, and 4 undergraduate courses on topics centered around human cognition and research approaches under her belt. When not in front of the computer, she enjoys the solitude of her garden, trying to recreate a bit of the magic from the old world, her homeland, where she spent summers walking across vineyards with a whistle to send away starlings, and falls picking hectares of grapes to make magic. And the two of them will now make magic in their presentation, and I'll see everybody after the session.
You may need a little bit of context there. I grew up in a village with less than 100 people and absolutely zero technology, and this whole virtual thing really makes me miss those days.
So, well, that was an interesting introduction, because I didn't know all those. I didn't know about starlings in your village of 100 people. So let's hop over to the talk, though. So the algorithm is not enough, and the subtitle is UX Meets Data Science, and in some ways it's really the subtitle that we're really focusing on. It's really about understanding an intersection between user experience design and data science that we're interested in, and we're going to kind of pick one aspect of that intersection to focus on, in the hope that it brings a new perspective that maybe you hadn't thought about in terms of how data science and UX can work together. So before we go there, though, we've got a poll, partly to just test and see if our polling thing works, and partly just to get our brains warmed up. So Roxana, do you want to fire the poll up? And we're asking, it's not a trick question, right? I think it's the second poll in the list of polls. If you were to suspect who's the least likely to be a data science expert of these 4 choices, who would you pick? And
so I think the poll is already there. So if you guys go next to the chat, you should be able to answer. And if for some technical reason you can't see it, feel free to just write your answers in the chat. But I do see answers coming in. It's happening.
So I feel like election night stuff here, right? We've already got, I'm going to call it. I'm going to call it early. We've got 13 votes already coming in for psychology and sociology.
No surprise yet.
I'm already biasing the results, I know. So if everyone is a statistician can call me out. So the reason we put out the poll, it's shifting a bit, but I think not surprisingly, sociology, psychology, anthropology is going to probably win. And if you look at kind of reliable surveys in this field, people tend more to come from math, stats, engineering, computer science when it comes to this field. And there's nothing wrong with it. It makes a lot of sense that people with those fields all have a lot of computer math backgrounds generally. And so it makes a lot of sense that people come from those fields. But of course, when you're solving problems and products and services and so forth out in the business world or other institutions, you need knowledge that goes beyond math and computing and so forth. And so we're really talking about how do you connect with people who might be more on the anthropology, sociology, psychology side, and also, unlike Roxana, maybe not that immersed and familiar with mathematics. So let's we can keep that. We can have a recount later if we need to or something, or we can protest it. But for now, let's leave the poll. One of the things that typically, you guys probably know, right, doesn't work to necessarily connect with people is the language of code or math, right? If it feels like this to people in those other fields, it's harder to connect to mathematics or coding and make that bridge between UX and data science or soft sciences and hard sciences. So what we're going to encourage you again at the end, you guys, there's a lot of expertise. Just looking at the list, we're going to encourage you guys at the end to reach out again, but just as a kind of almost a challenge to you. Let's go to the next slide. Our challenge in a positive way, did you switch slides? Is there's lots of ways, especially involving visualization. People are probably wondering, what could this be? Involving visualization, where you can communicate pretty complex math ideas, right? I'm sure everybody's read about, the metaphors of mountains and gradients and explaining gradient descent and so forth. This is actually something I constructed with my daughter when everyone used to be able to go out to lunch and breakfast and dinners together. This is a proof of the addition of an infinite series that Archimedes came up with. The infinite series is a quarter plus a 16th plus a 64th, 1/4 to the n, that he constructed over 2,000 years ago. And he got the right answer. It's absolutely correct. He got the right answer by constructing it. It has no kind of contemporary math. And yet you can talk about convergence and divergence and all those things. Obviously this doesn't have a direct application to AI, but the idea is there's always these opportunities to look for ways to explain mathematics in a way that's often visual or some other way other than kind of equations and code. And that's one thing we'd like you to kind of think about as experts in this field is, how do you find these other ways to bridge to people? Because we think we need that bridge so people can appreciate what AI, data science, and analysis does. So let's find out. I've made an assumption about you guys. We've scanned some of the profiles of who's there, but let's do the poll and get people's background on and people, again, we've already got people with their votes and info coming in. And it looks, again, that's interesting that we've got some people in anthropology, sociology, psychology. It's kind of encouraging.
I'm sure I brought them.
Your friend showed up there. But we've got a lot of, computer science, engineering, math, other, which of course we don't know what that is, could be anything other than those four. But we've got a lot of what we might expect at a machine learning conference. And so what we're gonna, let's go to the next slide. What we'd like to talk about is generally in this field, you guys, I'm sure everyone recognizes this, or a lot of people recognize these types of comics, which we've referenced at the bottom. It's quite popular in high tech and academia. But this cartoons one way of looking at how people think in these different fields, right? It's kind of, if you go left to right, it's this reductionist idea, right? That sociology can be reduced by an aggregate of psychology, psychology an aggregate of biology, biology an aggregate of chemistry, chemistry an aggregate of physics, maybe. And the thing we wanted to emphasize in, science is sort of funny, and then of course math, she's living all over there by herself with purity and truth and logic. But all these fields really do think about problems and attack problems in a different way. And yet when you're doing something like data science, you're trying to pull math into all of them, right? And we really believe, as you go left, it becomes trickier to pull the math in. And that's partly because, people are different than protons, and ideas emerge that are harder to make mathematical in a way, harder to write algorithms for. How do you, write an algorithm for justice or creativity or intelligence or culture? It's trickier than, orbits. So what we'd like you to take away from that is just be aware, if you're kind of grew up like I did on kind of the right side of this diagram, that when you're applying math to the left side of this diagram, there's accommodations and things to think about that the people in anthropology, sociology, and psychology might be aware of that you might not if you went through the kind of physics, chemistry, math background. Okay, let's go to the next slide. And here's a kind of broad way of looking at how some of those considerations come into play when it's AI working in a hospital or a university or in finance or something like that. There's absolutely the technical problem, the math problem, the algorithm, the AI, the technologies that have to integrate with each other. And it's essential, right? You need to get the technology and the algorithm to work, but it's not enough for the whole system to work, right? So if you're Roxana and I both have a fair amount of experience in healthcare. If your AI is in a hospital, right, there's a whole bunch of regulations and ethics that have to be considered. There are institutional cultural things about how people look at technology. There's, of course, the issue of trust and people, and do they trust the AI? Do they not trust the AI? Why? Right? So when we're talking about going kind of beyond the algorithm, or the algorithm's not enough, this is what we mean. Not about dissing what the algorithm's doing, right, or its importance, but adding to it these considerations around people, around ethics, around institutional practices. All these other things affect whether the algorithm can in fact be successful. So next slide, please. So,
that's good, I changed.
Yeah, I trust you. so it sort of begs the question, how do you do something formal like you do when you look at the technical considerations of the AI when you bring in people? Because you want this, one of the great things about technology and math and so forth is there's a lot of rigor around it. So when people draw architecture diagrams, and I'm sure you've all seen something like this, right? About how does this is actually from a product that Macadamian worked on that essentially scanned images in a hospital to make determinations of things like, is that bone broken and so forth. And so you need to think about what's happening in the process as the data is being passed around, as analysis is being done, as it's being interpreted, what's the format, all the ETL stuff, all those technical things you need to think about, cleaning the data and so forth. They're very rigorous and well thought out techniques, right? And then how reliable is the, what's the confusion matrix look like and so forth for the output. So you want to bring the same sort of rigor that you do on that technical side to the human side of it, right? So, what does that look like? And Roxana will be giving you some examples, but let's just go to the next slide. But what it looks like, you can skip this, go to the next slide. So what's it look like? How do you make the bridge, right? So there's kind of three places that are obvious where there's a bridge that can kind of be made, two of which I think people talk a lot about, and one, or at least somewhat about, one which we'll be talking about. So this is kind of a, if you're introducing how does AI work to someone for the first time, or how does machine learning, or how does even any algorithm mathy thing work, you often say something like this, right? You take the data about the system, the person, the hospital, whatever it is, you put it into the quote black box, it does its mathy algorithm stuff on it, it produces some sort of results which can be interpreted by a user to say, oh, look, that person has a broken arm, or we should, move this person from the ICU, or, this person's going to default on their loan, whatever it might be doing. And one of the places where AI and machine learning and data science and UX work together are that kind of results interpretation, right? Data visualization, that's a big part, and people spend rightly a lot of time there. Another place that's getting some attention is that the black box, right, is how do we make it a glass box? How do we make it explainable AI? Some things are easier to explain. You can kind of pull out what's going on. Decision tree is a lot easier than you can in deep learning or something like that. So there's progress being made in these areas to try and pull UX, because making the black box more glass box, for instance, does increase trust, right? So it's a great thing to kind of go after. But there's another way that people don't, or is less likely to look at kind of the bridge between UX and data science, and that's kind of at the data, or almost to the left of the data. So what happens before you put your data into a table or array, or index it, right? So next slide, please. And this requires maybe a little bit of a kind of break in thinking if you haven't been exposed to systems thinking and systems theory, but it's not hard. It's just something that we don't always think about, right? Often think about that the way the last slide sort of portrayed things. But when you're extracting data from a system, you've implicitly got some sort of model of the system there, right? You're saying, and what I mean by model of the system, you're saying what are the objects in the system, what are their attributes, what are their connections, because these are the things we gather data about, right? So if you go to the next slide, right, and often what happens, not always, right, but often what happens is you take the data that's kind of around, it's given to you by, sometimes called data exhaust. If you take something like an airport, right, and you're looking at people traveling and you're deciding you want to understand something about travelers, well, the business process has already kind of chopped up those travelers, for instance, into people flying business and people flying economy. And that becomes a category for which you can do analysis. Now, that may or may not be a useful category for answering certain questions. And that's the thing where I think UX can help, where we don't always think about it. We don't always think about the fact that category has in a way been chosen for us because of a business process, right? And when you think about, you go deep back into math and start, every probability course starts with Venn diagrams and sets, right? There's a reason for that, because that's what all this stuff is built from. So choosing your categories, choosing your sets, right, can make a huge difference on what you can answer and what you can't answer. So you go to the next diagram, for instance. Next slide. So I could put people into categories of business travelers and economy travelers, and you can answer interesting questions. You can, you can find out that business people tend to travel at the, last minute when they're going to New York or something, but not when they're going to, California or something like that. There's just tons of analysis that's useful that you could potentially do on those selected categories. There's a really interesting talk given by a woman, Indy Young, where she talks about trying to understand people's preferences for how they behave when it comes to carry-on luggage. And that is, if you're trying to understand, you're trying to create a system to improve basically their carry-on luggage experience. There's no pre-existing data or categories that really make sense. You have to go out and ask and find out, how do people think about their carry-on luggage? And it turns out she discovered that there's kind of 4 ways you think about carry-on luggage. And one of them, for instance, some people are very attached to their carry-on luggage. They're, they won't let go of their ukulele or whatever it is, and so they're gonna carry it on. And so these now become your 4 categories that you can do data analysis on, right? And there's no, and this is where UX can do something. It's one example. Roxana is going to give a whole bunch of different examples, but it's one example of how you can question the structures of the data already in your system that maybe you hadn't thought that you could question, right? That it's not just that they're business and economy travelers, and that's a way to partition, or this airline and that airline, or whatever is available. But you can inquire if you're trying to understand something else and understand other properties, other characteristics, and then use them as your kind of fundamental data constituents when you do your analysis. And that's an area where we think UX kind of is underutilized, right? Okay, next slide, please. So kind of generically, right, if I just summarize what I've been trying to get at there. And again, Roxana is going to give some examples here. Just like you include databases and so forth in systems diagrams, you can include people and include them as kind of dynamic components of the system. You can model people, right? You can categorize people, right? And that categorization doesn't have to be determined by the business process. It may be determined by other research, so that their preferences for their treatments, the thinking style, she calls them, about luggage, for instance. And given that, you can represent the larger ecosystem, which is the next slide. Right? No, that was good to go there. That was perfect, right? So not only do you want to think about the technical aspects of the system, but you want to think about all the people and their connections and involvements in the system. And that thinking is a great way of combining UX and data science, because you're both studying the same system, just using different techniques. And so before you get to I've got my data in my table or array or tensor or whatever, the step before is to do things like this. Look at the ecosystem diagrams. So, and Roxana will give an example. So I'll pass it off to you now.
Thank you. So I like this. I don't do this very often, but I like to start with a segue into my personal life. So last year I presented at TMLS, and I went to Scott, and I got really intimidated by the audience because it was outside of my comfort zone. I've been in human cognition, cognitive neuroscience, psychology, advanced stats, but definitely not pure data science. So the first thing that he asked me several things. He asked me where I'm presenting, who is the audience, and what is the audience's expertise. So in other words, he really wanted to understand the context and the larger, not so much the system, but the context in which this presentation will take place last year. And based on that, his advice to him was, you need to talk to them about things you're an expert and is of that value to them. So this long story, I guess, serves 2 purposes. For one is that most of the decisions, or the best decisions I've taken in my life, are based on a combination of both data, but also the context and the larger plan and picture, which sometimes data alone can miss. And I'm hoping to show that. And the second part is, of course, UX is huge. So we don't attempt to teach anyone UX over this, but if you take something away from this talk, is this idea of how important it is to understand the larger system. So in what follows, I'll root my examples in a university setting, just because that is very dear to my heart and because universities are going through lots of transitions during COVID. So I think it's an appropriate one in this context. So this is, as a researcher, as a UXer, this is one of the busiest slides that I've ever presented. And it's not something that normally I would do. But really, it's this busy and complex because it barely starts to scratch the complexity of a university system. And something that I'd like to draw, we've talked about looking at the entire picture so far, but I'd like to draw your attention to some of its main components. So let's say we're looking at it from the perspective of a student. Usually it's kind of easy to think of their close people, or it's easy to think of them as, okay, it's the student and the university. But really, we have both people and we have institutions. And the connections between all of them are really complex. When I showed this to my husband, just kind of practicing and getting feedback, his first question was, what in the world is the transit system in here? And I didn't answer. I let him stop for a second and just let him mull over. And that allowed him to take a trip down the memory lane in the pre-COVID era. And I'm sure that the time spent in traffic really resonates with all of you. So being in university, both as a student for so many years and as an instructor and in other positions, traffic is huge, but that's not something we would necessarily think of putting in paper without talking to the right people and asking the right questions. It would never come in any data set you might take from the university's HR with characteristics about students. How many hours it takes them on the bus to get from Stittsville to Carrollton. No one would consider that. So in what follows, I'll give you a few examples. The first one is something that universities are really trying to address right now, a very real problem. So we all know they're getting bigger and bigger as institutions, and the admission process is a very costly stage, both from a resource perspective, but also from a finance perspective. So this is one of those opportunities where the ideal solution is for AI to jump in to the rescue and solve this. But I'd like to show you what may be missed if we don't have an extended team that includes both the AI experts, but also UX expertise. So the real question here is, we're trying to identify the ideal candidate. So we have all of these characteristics, and we're trying to see how a person fits within the university. We want some data to evaluate whether they're a good fit or not. So the university's assumption here is that, or could easily be that, the ideal candidate will have the same characteristics that match those of historically successful students. And that's, they'll give you a data set, 20 years of data, thousands and thousands of rows. That's great. So the solution may be an AI tool that evaluates candidates based on this historical data. So what may happen? Well, let's say we have this person, Mary, and we look at one criteria, perhaps the grade. And if she doesn't have perfect grades or grades that were historically considered as successful throughout the university, she may be rejected. Similarly, maybe based on the name, she may be a woman And she's applying to a field that traditionally women were underrepresented. Again, she may be rejected for the wrong reasons. Once we start looking at other criteria, perhaps grade, work, experience, passion, if we have this other set of alternative criteria, all of a sudden she'll be accepted. But defining the set of criteria is somewhere where you may want UX expertise in. So some of the potential risks as taking this historical data set, I know the most famous one is discrimination, but really it's far more than that. It's all of these human biases that creep in, that when we look at the data set, they may just not be as clearly obvious. For example, recurrently recruiting in affluent areas. And this is a real problem that has been found. Another one is, we all know the problem of outliers. So if we look at historical data, any unique application may just pass on as an outlier and be rejected for completely wrong reasons and lack of representation in the system. So the solution here is to have someone that has a training of looking at the data from a cultural lens or from a completely more human-like lens to prevent some of these biases before they happen. Another example very dear to my heart is, well, not the failing part, but the idea of solving it, is seeing first-year engineering students failing. So universities have the right intention. They want to go in and they want to solve that problem. How do they do this? Well, their assumption is that these students are doing bad in first-year math and first-year physics because perhaps their grade 12 education was subpar. So they have the grades, but they just didn't learn the right things. So the solution is to have a predictive modeling or a classifier to kind of see in the early days of the semester, if they have a bad grade or if they underperform in these core subjects, then they are placed in a course, an extra course. It's called PASS at some universities, but basically they're offered extra help to be able to allow them to catch up. That sounds pretty reasonable. We see they failed their first midterm. That means something went wrong, and let's help them. In isolation, it sounds like an ideal solution. So what happens here is that the university assumes this system. And they kind of assume a very limited siloed system where we have the student who's underperforming, the high school where they got the grades, but really they don't have the knowledge, and the university where they are now underperforming. And within this minimal system, the solution of their interpretation and assumption is very likely, and the solution would be ideal. But the problem is we're dealing with an assumed system. The real system looks more like this. We have the person, we have the university, we all know what's happening in Armenia right now, for example. Lots of students in today's society work, others are adults with kids in daycare or lack of daycare right now, financial situations, international students, and this is only a glance of what may be part of their system. Heck, at the end of the day, the pub should be in there too. There's so many who move away after grade 12 and things just go wrong with unlimited access to the pub and limited supervision. So all of these components are completely omitted in the assumed system they had. So really, once you start looking at all of these and considering all of the elements, you start identifying a lot of other barriers. Some students are underperforming because of their English proficiency. Others because they just can't make it in terms of schedule or dedicate the right hours. I've seen students perform just because they've never used a Scantron and everything goes wrong. So really, this assumption of the below standard grade 12 education is a really small component of the reasons of why they may underperform. But it's the only one being addressed because it's the only one identified or assumed in this case. So the problem here is that the university has made an assumption, which it's oftentimes we start with that assumption. And it's quite reasonable in that subsystem where we only have the high school, the student, and the university. But where the problem really comes in is when they don't go ahead to validate this assumption and identify that there's a lot more going on. So the solution here would be to map that system and observe the students, listen to them, ask them the right questions to really understand all of the barriers that would never make it in an Excel data sheet because those questions are not being asked. Another one that really pains me is that mandatory class attendance is still a thing. Students are supposed to be in class and participate. And this is just something that's aggravating an undetected problem. So there's some sort of student-professor misalignment. Universities have this not so tacit, they reinforce it quite vividly that students must attend and fully participate in courses. Even now on Zoom, some request turn on your camera. And the solution, and I've received this as part of my training as an instructor, was to really give grades for participation and punish, basically, students for limited attendance or participation. So once again, we're kind of thinking of this, we're revisiting the assumed versus the real system. So in a student high school or just student university system, where that is their whole universe, there'll be absolutely no reason really for a student to miss class. That's their full-time job. That's everything. But in reality, there's multiple barriers as why they may not be there. And punishing and reinforcing that is just amplifying a problem that they don't necessarily is not necessarily acknowledged as existing. So here, once again, we see the problem is that we're looking at what should have happened somewhat based on a historical data set. But today's population is a lot more diverse and everyone's needs, users' needs in any environment are constantly changing. And universities have not necessarily caught up. So the real solution here is to listen to stakeholders' voices, identify all of those stakeholders, first of all, map the larger ecosystem, and reiterate, because there's always change. And Scott, I'll pass it back to you.
All right. Yeah. Life here. Okay, so just to kind of summarize what Roxana indicated, I think, with those examples, is that the opportunity, and this is an opportunity, I can't overemphasize this, for data science and UX together, not just one or the other, right? Is when you model the whole system, like she showed in the example of, you just think about the university and the high school versus, you know, the student, the university, the pub, all the other things. There's an opportunity for deeper understanding when you model the whole system and try and understand a problem for instance, why a student is doing poorly or well from an entire system perspective, all the things they're interacting, right, with. And of course, these systems now, looking at them, explicitly include people and characteristics of people that matter for how they behave, right? And you need both qualitative and quantitative data, and they can play off each other, right? When you model the bigger system and you identify something about people's behavior going to the pub or not, it opens things up for data science, right? The psychologist, UX person, anthropologist, whoever it is who brought you that, quote, kind of soft data, has now opened up an area where you can bring in the magic of data science and attack the problem with, quote, hard data. Right? So they're playing off each other. It's not about one kind of winning over the other. They play off each other. Next slide. So we've recommended some books that are, they're not about UX so much, right? If I had to pick one of these, I'd pick the one in the middle. They're about places where you can indirectly, in a way, find some common ground for UX and data science, or more broadly, kind of hard and soft sciences, right? The mixed methods is really about research techniques that are quantitative and qualitative and bringing them together. The calling bullshit one's a bit negative on AI, but if you kind of can step back from that a bit, it does point out opportunities for how you can make it better by considering things other than the pure kind of technical problem. And the one I'd recommend is this by Donella Meadows, if you're just going to read one, because it's a very foundational, how do you think about holistic systems and how different elements interact. And she's got a whole bunch of math in the back, right? So anybody can read it. You can read it kind of in a low math way. And look at it, but she's also done a great job of analyzing it from a more mathematical standpoint, which is a lot of thinking in system type books. They haven't done that separation as well as she did. Okay, next slide, I guess. I think we're...
Before we move on, there's also a link to a paper that Scott is modest enough not to bring up, that he co-authored with Jennifer from Macadamian. And it's a really great paper to kind of help you identify as an organization where exactly you stand in terms of your maturity and what's the next step from a UX perspective, obviously. Okay, and we want to leave you with one last wish. So we kind of focused on what UX can bring to data science because of the audience. And we know the audience is data science experts, but really it goes both ways. So we'd like to kind of continue this conversation and really invite you to also apply to more qualitative and UX conferences, because we think, like Scott reinforced, it's really a fine balance, and it's a marriage between the two. So we'd love to see you involved in our world as well. Thank you.
Great. Thanks, guys. That was fabulous. So I just want to reiterate to everyone who's listened to the talk to please, if you have any questions, post them in the session chat. And I'd be happy to ask them on your behalf. I did have one question about the paper. Can it be linked? And I believe that is linked in the slide itself, so you should be able to get access to that. One question that I had, that I think a lot of people have on their minds, is if anybody were to start to try to bridge this gap, what would be a pragmatic place to start? Like, how would they go about bringing in, so if you're a data science group, or you're a UX group and you need to integrate one or the other, how does one get started? How do you bring these people together to form that multidisciplinary team and approach?
So, I think you want a common way to look at a problem, right? So one practical way that we found works really well is those diagrams that we showed a few times, that Roxana showed, right? If you can literally just draw the picture of the problem you're trying to solve, it can have a huge impact on the discussion that you have around those problems, right? So literally, I mean, we used to joke about, you guys know this, right? We'd lock up our clients in a room, which unfortunately we can't do in COVID times, but for 2 or 3 days, and really just talk about the problem. And if you look at, you know, if you just look at kind of the history of on the data science, the physics, the mathy side of solving things, people visualize, the first thing you do in like a first year physics class is learn how to visualize problems of, you know, firing a clown out of a cannon and where he's going to land or something. So that visualizing the problem space with everybody, the data science, the UX people, the engineers, the product people, is super powerful. And there's already a lot of that visualization done. Like we showed you that, you know, the databases and so forth, diagrams. You just need to expand it a bit, right? And I don't know if you have anything you wanted to add, Roxana, or, you know, or Lorraine. I mean, you do this too, right?
I think that's it. I think that's what I find the most helpful, kind of try to transition between the two worlds.
Yeah, definitely. I would agree. So having, even if it's just a joint effort to apply different perspectives, and that ecosystem map is the perfect place to do it, because people will see different things from different perspectives. And it's always, you always build a bigger and better picture because of it. Agreed.
I guess
oh, go ahead.
I was going to say, I guess another thing that comes to mind is kind of having that middle person who maybe is not a data science expert, but knows enough advanced stats to really understand the language of both. So they can still look at an algorithm and translate it back or disseminate it back, like a middle of math knowledge, if you wish.
Okay. Another question, and probably the last one we'll be able to ask, since I believe we're coming to the end of our session, is just when you, so Roxana, you talked about doing research and the importance of providing that qualitative, those qualitative insights. So what do data scientists do with that then? So how might that, and this might be maybe more of a question for Scott, but how might that tangibly affect data sets and how you work with them?
So do you want me to take that, or do you want to try it?
I'll give it a try. I'll let you advance it.
Well, don't count on that. It might, I might go backwards, but go ahead.
I think the first thing I can think of is whenever I've done even basic unsupervised learning, one of the hardest parts that and the most time consuming are data cleaning. And I think if you do that step and data pre-processing and look at the variables through a different lens, you'll have other tools at your disposal to come up with that ideal set you'll conduct your analysis or training on. Whereas from a purely data side perspective, I may look at variables that I'm not supposed to have in there by law or correlations, but I may see something else through a more cultural or human lens. And the other one is kind of going back to the Indie Young example, where it's just giving you ideas of other ways to classify the subsets within your data that otherwise you would never think of.
I think that's a great answer. I mean, in the end, all that model does work. You feed a vector into a box, right? And it spits out a result. And how you choose, well, there's data science methods for reducing dimensions and things like that. There are non-mathematical ways of emphasizing certain, or deciding to emphasize certain variables, or eliminating them, or creating new ones. Like the categorization is a great example. So you're always going to feed some vector into a computational quote machine, even if it's a person. And so choosing that is it is a choice. It's not something that just happens to be like, oh, and we're often just, here's the data, do something with it, right? You can do better than that, right? And once it comes out and you're refining the model, that's another place you can go back and go back to the doctors, if that's who you're working with, and like, wow, it's suggesting this, and they're like, wow, I haven't seen that kind of, I haven't seen blood pressure ever being important or something. So I don't know why the decision tree is making it so important, right? They could be right, they could be wrong, but at least you're playing off each other's expertise.
Sorry, you just made me
Great.
think of something else last comment. So I think another one, just because we're in a COVID time right now, another one is, from my experience with data science, is that algorithms are kind of reiterated and revised on a kind of standard every X period of time cadence. But really, UX can also give you a more informed, contextual way to decide when there's a need for that, because something has changed externally that will have a huge impact.
Absolutely. Yep. And I think that's a great point to end off with. I'd like to thank everybody for attending the session, and thank you to Scott and Roxana. That was an excellent session, and everybody enjoy the rest of their afternoon.
Thanks, guys.
Thank
Bye.
you, everyone. Don't hesitate to reach out to us.